All right, welcome to session 4, everyone. This is it, the final session of phase 1. And I know this is the one so many of you have been looking forward to. It's time to make all that hard work pay off and really make our data come alive.
Okay, so before we jump in, I really want to give a huge thank you to our amazing partners at the University of Cape Coast, specifically the Center for Data Archiving, Management Analysis and Advocacy, and the Department of Data Science and Economic Policy. Just as a quick reminder, this is session 4 in our 12-part program on foundational knowledge in data science and AI.
All right, let's do this. Look, over the last 3 sessions, you have done the heavy lifting. I mean, you've loaded data, you've wrestled with it, cleaned it up, and you've even learned how to summarize it. Well, today we get to finish that journey. Today, you're going to stop being just a data wrangler, and you're going to become a data storyteller. All right, section 1, seeing the story. You know, a table full of numbers. It's accurate for sure, but it doesn't really speak to you, does it? A great chart, though, that's different. It can show you the entire story, the patterns, the surprises, all in one single glance. It's all about turning those endless rows and columns into actual insight.
So this brings us to what is maybe the single most important rule of the day. You absolutely have to match the chart you choose to the question you're asking. Let's start with the basics, the bar chart. Its job is super simple, but it's incredibly powerful. All it does is compare values across different separate categories. Think of it like a lineup. You're just seeing who's tallest. We use it to see things like which market has the highest prices. It's a straight-up comparison of different groups.
A line chart, on the other hand, is all about telling a story over a sequence, and that sequence is almost always time. It literally connects the dots to show you a journey, right? How something changed from January to February to March. Then you've got the scatter plot. This one's our detective tool. We use it when we're trying to figure out the relationship between 2 different numeric things. Do they go up together? Does one go up when the other goes down? Every single dot on that plot is a piece of evidence. And this all leads to a crucial point. I really want this to stick with you. Getting the chart type wrong is not a stylistic mistake. It is an analytical one. Think about it. If you use a line chart to compare markets, you're basically saying that Kumasi comes after Cape Coast in time. That makes no sense, right? It's complete nonsense. The tool you pick has to fit the job you're trying to do, period.
Okay, enough theory. Let's get practical. In this next part, we're going to take these rules and apply them to some real Ghanaian data using the Plotly Express library. Let's answer some real-world questions. So here's our first mission. It's a classic comparison problem. Which market has the highest average tomato prices? See what we're doing here? We have separate categories, the markets, and we want to compare one number, the average price, across all of them.
Now, you already know how to get to this point, right? Back in session 3, you learned how to group and summarize your data to create a table that looks exactly like this. And yeah, we can read the numbers, but a chart is going to make that comparison totally instant. So based on our big rule, what's the right tool for the job? Well, since we are comparing one value across a bunch of different categories, it's got to be the bar chart. It's the perfect tool. Each bar is going to be a market, and how tall it is tells us the average price. It's simple, it's crystal clear, and most importantly, it's the right way to do it. Okay, let's try a totally different kind of question. How about this? How has monthly rainfall changed over time in the Central and Ashanti regions? Did you catch the magic words there? Changed over time. That's our big clue. It tells us we're hunting for a sequence, a trend. And you guessed it, that means a line chart is our go-to. We're going to put time along the bottom, rainfall going up the side, and just see what the pattern looks like. Now, there is a little technical thing here you'll need to do. You got to make sure that your date column is actually in a proper date time format so that Python knows it's a sequence and not just a bunch of random numbers. Okay, and for our third example, let's tackle something a little more complex. Here's the question. What is the relationship between monthly rainfall and the price of tomatoes? You see, now we're not just comparing things or tracking them over time, we are investigating a possible connection between 2 totally different numbers. And for that job, we need the scatter plot. Every single dot on this chart is going to represent one single observation, so 1 month in one region. And we'll plot its rainfall on one axis and the tomato price on the other. And to make things a little easier to see, we can even add a trend line. It's just a simple line that helps our eyes see the general direction of the relationship, if there even is one. So making a beautiful chart, that's only half the battle. Seriously. Now we have to learn how to read it and how to talk about it like a professional. So let's dive in and learn how to interpret like a pro. Look, before you even try to figure out what a chart is saying, you have to stop and ask yourself a few questions. It's like a checklist. What's on the horizontal axis? What's on the vertical axis? What do the colors mean? What are the units we're talking about? What's the main pattern I see? But honestly, the most important question, and the one people always forget to ask, is this. What is the single biggest limitation of this chart? What can it not tell me? Okay, now for what might be the single most valuable tool I can give you today. I want you to burn this into your brain, the two-sentence interpretation. It's a template. Sentence 1 is the pattern sentence. You just state the main thing you see and you include a specific number. Sentence 2 is the caution sentence. This is where you state what the chart cannot prove. And listen, this is not a weakness. It's the exact opposite. It's a sign of discipline. It proves you know the limits of your own data. Now, a quick word of warning. You have to know that charts can be used to mislead people, even when the data itself is perfectly accurate. If you start the vertical axis at, say, 50 instead of 0, you can make tiny little differences look like huge mountains. If you lump different groups together without checking, you can hide really important details. Or if you use raw numbers instead of percentages, you can make things look way more dramatic than they actually are. These aren't mistakes, these are choices an analyst makes. All right, it's time to bring it all home. This is it, your complete Phase 1 workflow. This connects every single skill we've talked about, all the way from Session 1 right up to this very moment. Just look at this. This is the whole journey, from a messy data file all the way to a finished insight. You load it, you inspect it, you clean it, you filter it down to just what you need, you group it and summarize it, you make a beautiful labeled chart, and then you write that brilliant, cautious two-sentence interpretation. You now have the entire chain of skills. Every single thing on this list is something you have actually done. I really want you to take a second and just appreciate what you've done here. This isn't just about learning to code. You have built 7 incredibly powerful analytical habits. You now ask clear questions, you know how to navigate the collab world, you understand how tables work, you inspect your data, you clean with a purpose, you visualize to find patterns, and you interpret with caution. These, right here, are the core habits of every single great data analyst. And with that, you have officially completed Phase 1. The foundation is built. You are absolutely ready to start asking and answering much, much harder questions. Congratulations, you've earned it. So what's next? Where do we possibly go from here? Well, we start asking questions like these. The patterns we're seeing in our charts, are they actually real, or are they just random noise? The difference in price between two markets, is it big enough to actually matter statistically? And maybe the biggest question of all, can we use everything we've learned about the past to actually predict what's going to happen in the future? That is what's waiting for you in Phase 2.